Hi everyone. Here you are going to learn about a very small and very interesting topic. It's a very simple topic. It's called as the interconnection of two-port networks. Okay, basically what it means is that we are just going to take two simple two-port networks and then we'll connect them. Okay, we'll connect them and then we represent their overall parameters based on their connection. Okay, that's what it means is that you see we just take a one two-port network. Let it be N1. I will take another two-port network that is called as N2. Okay, and then based on how these two networks are being connected, I can represent their individual parameters. Okay, I can represent their individual parameters using basic equations, and then from there I can find the overall parameter equations. Okay, so here we know that for a two-port network means basically each port is represented by two signal lines. You see, these two ports, right? This is the input port of N1, this is the output port of N2, this is the input port of network N2, and this is the output port of network N2. You see, so how can these two port networks can be connected together? How can we join both of them? There are 5 ways of connecting these two networks. These two, or in other words, there are 5 ways of connecting any two-port networks. Any two-port networks. Okay, the first connection we have is the cascade connection. The other one is called as the parallel connection. The other connection is called as the series connection. The other connection is called as the series parallel connection, and the last is called as the parallel series connection. So what you have to do is, all you have to do is simply understand the meaning of each and every type of connection. Once if you understand the basic meaning, then representing their parameters will be very easy. If these two networks are connected in cascade, then we can represent them using their individual ABCD parameters. If these two networks are connected in parallel, then we can represent them using the individual two y parameter, basically the y parameter of this and y parameter of this. We can basically represent their overall parallel connection using y parameters. If you are connecting them in series, then you can represent them using their individual Z parameters. If on the input side, if the input side of one network is connected in series and the output side is connected in parallel, then you can represent the overall network in terms of the hybrid parameters. And if the input side is connected in parallel and the output side is connected in series, then you can represent the overall network in terms of the inverse hybrid parameters. These are the different ways of connection. Okay, so the thing is, which parameter should we use for which connection? That is what you need to remember. And remembering that, let me tell you, it's very easy. I'm going to explain that to you how it is being done. Okay, so first, the most important thing is that just simply understand the meaning of these individual words. That's all you have to do. Once you understand that, then you will know definitely by remembering the definition of these words, then from there you can find out which parameter you are supposed to use, and from there you can represent this corresponding overall network. That's all. That's all you have to do over here. Okay, so let's take one. Let's take cascade connection. So I'm going to explain to you what is cascade connection. All right. So what is the meaning of cascade connection? Cascade connection means if two systems are joined in such a way that the output of one system is connected to the input of another system. That's all. That's the meaning of cascade. The output of one circuit or one network is connected to the input of another network. Then we can say that the two networks are in cascade. That is called as the cascade connection. Okay. So in cascade connection, like I said, we are using ABCD parameters. Why? We already know there's another name for ABCD parameters. ABCD parameters is also called as the transmission parameters. Okay, let me explain to you why. See, for that, you know what I'm going to do is I'm going to take one network. All right, let's draw one network. Let it be any network. It can be a combination of resistors, capacitors, inductors, etc. Okay, so I'm going to take one network. And this network, the name of this network is N1. N1 is full of resistors, inductors, and capacitors, all different combinations of all that. Okay, so let's take a network N1, and you know what I'm going to do is I'm going to mark the input voltages, input current, and output voltages and output current of this network N1. And this is how I'm going to mark. That is, the input voltage is called as V1 dash. Okay, V1 dash is called as the input voltage of N1, and I1 dash is the input current of N1. and I2 dash is the output current of N1, and V2 dash is the output voltage of N1. Okay, so this is the story of N1. So in that case, what is the ABCD equation for this network N1? What is the ABCD equation of network N1? You see, I'm going to represent them in terms of its matrix form, not in the normal form, okay, not in the equation form. I'm going to represent them in the matrix form, because representing them in the matrix form will be much more easier, and this portion can be easily be covered, very easily can be covered. So we all know what is the equation for ABCD parameters, right? It is called as V1 dash I1 dash. Since the name of the current is and the voltage is now V1 dash and I1 dash, I'm going to give the name just like that, okay? V1 dash I1 dash is equal to, and let their ABCD terms be represented as A dash, B dash, C dash, D dash, okay? Is A dash, B dash, C dash, D dash into V2 dash and minus I2 dash, okay? This is how this is the ABCD parameters of network N1, okay? Okay, we are using the term using V1 dash, I1 dash, V2 dash and minus I2 dash, okay? Otherwise you can just see the equations like that. The equation is V1 dash is equal to A dash V2 dash minus B dash I2 dash, and I1 dash is equal to C dash V2 dash minus D dash I2 dash, okay? But representing them in matrix form is much more easier, okay, in this chapter. So this is the story of network N1. Now what I'm going to do is that I'm going to take another network, and this network is called as network N2, okay? And this network has its input voltage is represented by V1 double dash, and its input current is represented as I1 double dash, and here also the output voltage is represented as V2 double dash, and the output current is represented as I2 double dash, okay? This is called as network N2. So now how can I write the ABCD matrix equation of this network? In that case, the equation would become V1 double dash I1 double dash is equal to A double dash B double dash C double dash D double dash into, and here the output voltage is V2 double dash and I2 double dash, right? So we say it as V2 double dash minus I2 double dash. This minus is coming because there is some negatives in the equation form. That's why, okay? That's why we are representing it as a minus equation, okay? So this is how it. Now what happens if I connect them in cascade? What happens if I connect both of them in cascade? So in cascade connection means that the output of one network is connected to the input of the other network. That's all. There's nothing else. So which means that I will just take network N1, okay? There. This is network N1, okay? And then what I will do is, this is N1, this is I1 dash, this is V1 dash, okay? This is I2 dash, and this is V2 dash, okay? Plus minus. Now what I'm going to do is that the output of this, or the output of this network is connected to the input of the second network. So it will be looking like this. This is called as the cascade of two-port networks. And here there's a current called as I1 dash, and here there is a voltage. The input voltage of this is called as V1 double dash, and this is called as I2 double dash, and here plus or minus, this is called as V2 double dash, okay? So this is the overall story. This is what happens when two networks are connected in cascade. So what will happen if two networks are connected in cascade? Very easy to remember, right? What will happen if these two connections, one thing, according to this connection over here, you see over here, first and foremost, you can understand that the output voltage of the first network is equal to the input voltage of the second network. That is the first thing you have understood. See, Here we could see that when the output of the output port of one network is connected to the input of the other network, then the output voltage of the first network will become equal to the input voltage of the second network. That is the first thing you have that's what happens when the two networks are connected in cascade. The second thing you need to understand is that if you look at the current, the output current of the first network is in this direction and the input current of the second network is in this direction. I mean, this branch has two opposing currents. One is in this direction called as I2 dash, the other is in this direction called as I1 double dash. It is I1 double dash, okay? I1 double dash, okay? So in that case, what is the name of the current? This is called as I2 dash is equal to minus I1 double dash. So this is how we represent the cascade equation. When two-port networks are connected in cascade, this is what happens. That is, the output voltage of the first network is equal to the input voltage of the second network, and the output current of the first network is the minus of the input current of the second network. That's what this means. From here itself, if you have really understood the ABCD parameters, you can understand the reason why we are choosing ABCD parameters to represent the cascade. It's all in this equation. You see, it's all in this equation. So let's see what happens. All right. So like I said, what I'm going to do is that first I am going to write the parameters, the ABCD of the first network, and that is, let me write, that is for N1, for network N1, we can say that V1 dash I1 dash is equal to A dash B dash C dash D dash into V2 dash and I2 dash minus I2 dash. Okay, minus I2 dash. So now what happens is that I'm going to substitute this value in terms of this value over here. We already know that V2 dash is equal to V1 double dash, and I also know that I2 dash is equal to minus I1 double dash. I'm going to substitute these two equations in this matrix form. If in that case, then how does it look like? In that case, this will look like this. That is, this will now become V1 dash I1 dash is equal to A dash, B dash, C dash, D dash, and here V2 dash is equal to V1 double dash. So V2 dash is equal to V1 double dash, and I2 dash is equal to minus I1 dash. So minus of minus becomes plus. So this is nothing but I1 double dash. You see, look at the beauty behind this. Now what happens? Now we already know the equation for this matrix. V1 double dash and I1 double dash, right? That is the nothing but the matrix of the second parameter. You see, the second parameter equation. So just substitute that over here. So you will get V1 dash I1 dash is equal to A dash, B dash, C dash, D dash. And instead of this matrix, we can write the matrix of this equation. So this will become A double dash, B double dash, C double dash, D double dash into V2 double dash and minus I2 double dash. Okay. So now take a look at this interesting equation. What is V1 dash and I1 dash? V1 dash and I1 dash is the input voltage and the input current of the overall network. The input voltage is V1 dash and the I1 dash is the input current of the overall network. That is after when these two networks are connected in cascade. That is these two parameters, okay? And also, what is these two parameters? V2 double dash and I2 double dash, that is nothing but the output voltage and output current of the overall network. V2 double dash and I2 double dash is the output voltage and output current of the overall cascaded network. You see, so what is that? So what we have found here is that if these two networks, if you want to represent the ABCD of the overall network, if you want to represent the ABCD of the overall network, the equation will become V1 dash I1 dash is equal to A, B, C, D, where this matrix A, B, C, D is the ABCD parameters of the entire network, of the entire cascaded network, and the output voltage of the entire cascade network is V2 double dash, and the output current is minus I2 double dash. Okay. So when you see these two networks, we can say that the overall ABCD parameters, the overall ABCD parameter of this equation can now be, by comparing these two equations, the overall ABCD parameters of the cascaded network is given by ABCD is equal to A dash, B dash, C dash, D dash, and into A double dash, B double dash, C double dash, D double dash. See, this is what happens when two networks are in cascade. That is when you connect the two networks in cascade. When you connect the output of one network to the input of another network, then the overall ABCD parameters, the overall ABCD parameter of the entire system, of the entire circuit, is nothing but the product of the individual ABCD parameters. Okay, so if you want to find the ABCD of this overall, if you want to find the ABCD of this overall network, all you have to do is take the ABCD of this network and take the ABCD of this network and multiply both of them. Simply multiply both their parameters. This is what is called as the cascade of two networks. This is what happens when the cascade of two networks. So you just have to remember that for cascading of two networks, the individual ABCD parameters will be affected like this. Okay. Next we have is the parallel connection. Okay. So what is the meaning of the term parallel connection? What is the meaning of the word parallel connection? You see, we have already know the meaning of this. Parallel connection means the current gets divided. Right? The current gets divided and the voltage across the parallel elements are the same. That is what we call as the parallel connection. That is, if two elements or if two networks are connected in such a way that the voltage across each network is the same and the current gets divided, then we can say that the two networks are in parallel to each other. So if you want to draw the parallel connection of these two, so this is network N1, this is network N2. I'm not going to mark the voltage and current over here because it might confuse you later. So you know what, and these are the two networks. Now what I'm going to do is that I'm going to draw the parallel connection of these two networks. So how does it look like? Right? It looks like, it's very simple. You see, I'm going to draw, this is network N1. Okay. This is network N1. Let me draw like this. Okay, right, this is network N1, same network over here. Okay, I'm just drawing it again, that's all. And then I'm going to draw network N2. Okay, I'm going to draw network N2 like so. Okay, so again I'm saying, when does two network is said to be in parallel? They are said to be in parallel if the voltage across the two networks are the same and the current is the one that gets divided. Then we say that the two networks are in parallel. What it means is that if I connect this network, the first signal line to the first signal line of N2, the second signal line to the second signal line of N2 at the input side and also at the output side also, the first signal line is connected to the first signal line of network N2 and the second signal line is connected to the second signal line of network N2. This is what we call as the parallel connection. This is how we represent the parallel connection. See what happens over here? You see the input, let N1 be the input voltage. Okay, let V1 be the input voltage of N1. If V1 is the input voltage of N1, then V1 is also the input voltage of N2. You see, so both of them have the same input voltage. Also in the case of the output voltage also, if V2 is the output voltage of N1, then V2 is also the output voltage of N2. That's one definition of parallel connection, but that's not the only definition. The other thing is that the current gets divided. You see, if there is a current called I1 over here, if there is a current gets of I1 over here, that current will get split into two different networks. That is, this will here the current gets divided over here, and the name of the current of in network N1 is I1 dash, and the current over here is I2 dash. Okay, same in the case of the output current also. If there is a current called I2 like this, then that current will get divided, and I2 dash is the current of the I2 dash. Let this be I1 double dash. Okay, I don't have to give the same meaning, right? I1 double dash. Okay, and so here this current I2 dash is the current into this network, and I2 double dash is the output current of the second network. You see, so this is what happens. So basically you need to understand that when two networks are connected in parallel, the current gets divided. Okay, and the rest of the parameters are the same. Rest of the parameters, the voltage is the same, but it is the current that gets divided, or it is the current that gets affected. See, you see here, according to this, I1 is get divided into I1 dash and I2 double dash. And here also I2 is equal to is get divided into I2 dash or I2 double dash. Or in other words, when two networks are connected in parallel, then we can say that the current equation is represented as I1 is equal to I1 dash plus I1 double dash. That is, I1 is the overall input current of the overall parallel network. I1 dash is the individual input current of network N1. I1 double dash is the individual current of network N2. And also, if you take in the case of the output current also, I2 is equal to I2 dash plus I2 double dash. That means where I2 is the output current of the overall parallel network, and I2 dash is the output current of network N1, I2 double dash is the output current of network N2. So we can say that I2 is equal to I2 dash plus I2 double dash. Okay, so now what do you now you ask yourself, which is the which parameter we use in order to represent the parallel connection? Or in other words, which parameter do you use to represent the current equation? That parameter has only one name, and that is nothing but the admittance parameter or the Y parameter, because the Y parameter network is given by the name. We know that Y parameter, the equation for Y parameter for any network, okay, for any network, comma, the Y parameter equation is given by I1 I2, right? I1 I2 is equal to Y11 Y12 Y21 and Y22, right? We know that, right? And this is into V1 V2. This is the Y parameter equation. Alright, so we are choosing the Y parameter equation because the Y parameter equation is basically nothing but the equation for representing the current, and here it is the current that is being affected. That is why we are using the Y parameter. So you need to understand that. That's how you need to remember this. Okay, which, like I said before, I'm going to explain to you how which connection we are using for which network parameter. So like we have already learned that for cascade connection we use the transmission parameters, and for parallel connection we are going to represent the overall network using the Y parameter equation. Okay, so to represent the Y parameter equation, what I'm going to do is that I'm going to represent the individual Y parameters of the network. Right, so for network N1, right, if you are taking the case of network N1, let me write it. For network N1, right, how do you express the Y parameter of this equation? The input current is I1 dash, the input voltage is V1, the output current is I2 dash, and the output voltage is V2. So therefore we can say that for network N1, the Y parameter equation is given by this I1 dash, I2 dash is equal to, let Y1 dash, Y11 dash, Y12 dash, Y21 dash, Y22 dash is the Y parameter of network N1. So in that case we can say that this is Y11 dash, this is Y12 dash, this is Y21 dash, this is Y22 dash, and what is V1? Is the input voltage of N1, and what is V2 is the output voltage of N1, and both of them have the same voltages. So this is how we write them. This is for network N1. What about in the case of network N2? For network N2, okay, there for network N2, the input current is I1 double dash and the input voltage is V1, and the output current is I2 double dash and the output voltage is V2. So we write it as like this, that is I1 double dash, I2 double dash is equal to, and here you will just use the double dash, so it will become Y11 double dash, Y12 double dash, Y21 double dash and Y22 double dash, okay, into, and the voltages are basically the same. Okay, you see, this is how we represent them. Okay, and this can, so we already know the equation, we already know that I1 is equal to I1 dash plus I1 double dash, and also I2 dash is equal to I2 dash plus I2 double dash. Or in other words, the matrix that we say, the matrix that is the I1 I2, okay, I1 I2 matrix, that is this matrix, that is the matrix of the overall parallel connected network, of the overall network. I1 I2 is the I1 is the input current of the overall network, I2 is the output current of the overall network. So I1 I2, okay, so I1 I2 can also be written as, using the basic equation, we can say that I1 is nothing but I1 dash plus I1 double dash, and what about I2 is also called as the I2 dash plus I2 double dash, right? That is, we can write this matrix form in this form also, right? Because basically these two, this is nothing but the sum of these two current, and this is nothing but the sum of these two current, okay? And in that case, this can also be written like this, that is I1 dash, I2 dash plus I1 double dash, I2 double dash. See, we can write like this. But we already have the equation for I1 dash, I2 dash. We also have the matrix equation for I1 double dash and I2 double dash. What is the equation of I1 dash and I2 dash? That is nothing but, it's nothing but Y11 dash, Y12 dash, Y21 dash, Y22 dash into V1, V2 matrix. That is for this term, plus, and for this matrix the equation is this one right here, Y1 double dash, Y12 double dash, Y21 double dash, Y22 double dash into V1, V2. This is it, right? Here you can say that these two matrices, right, are common. This matrix V1, V2 and V1, V2 over here are common. So I can take them outside. So this will become I1, I2 matrix is equal to, and this can be written as, I'm going to write like this, okay, just so that you will understand. Y11 dash, Y12 dash, Y21 dash, Y22 dash plus Y11 double dash, Y12 double dash, Y21 double dash, Y22 double dash into V1, V2. See, becomes like this. Okay, now what I'm going to do, I'm going to write the sum of these two matrices. What is the sum of these two matrices? It can be written as I1, I2 is equal to, this can be written as Y11 dash plus Y11 double dash, and the other one is called as Y12 dash plus Y12 double dash. Here this is called as Y21 dash plus Y21 double dash, and this is nothing but Y22 dash plus Y22 double dash, okay, into V1, V2. See, this is how the matrix becomes. Now if you compare this equation to this equation right here, okay, this is the equation for the overall parallel connected network. This is also the equation of the overall parallel connected network, because here I1 and I2 is the overall input current and output current of the network, of the overall parallel network. Likewise, V1 and V2 is the input voltage and output voltage of the overall parallel connected network. So in that case, by comparing this equation with this equation, we can say that y11, y12, y21, y22. Okay, this is nothing but the y parameter of the overall parallel connected network. Okay, this is nothing but the overall y parameter of the overall connected network, and this is equal to nothing but the is equal to the y11 dash plus y11 double dash plus here y12 dash plus y12 double dash, and this is y21 dash plus y21 double dash, and this is y22 dash plus y22 double dash. That is, from here what you have understood is that if two networks are connected in parallel, okay, if two networks are connected in parallel, then the overall y parameter of the network, is nothing but the sum of the individual y parameters. Okay, it's a sum of the individual y parameter networks. That's what you need to understand. That is the only significant thing about the parallel connection. That is, when two networks are connected in parallel, then we can see that change in their y parameters. How? By simply adding the y parameter of this network with the y parameter of this network. Okay, that's all. That is the parallel connection. Next we have is the series connection. Okay, so when do we say the two networks are in series? When do we say the two port networks are connected in series? Or what is it? That's what here most of them will be confused with the word series connection and cascade connection. Cascade connection means, the basic definition of cascade connection means that the output of one network is connected to the input of another network. It's as we join them by connecting the output of one port to the input port of the another network. That is called as the cascade connection. Okay, so now what is the difference between cascade and series connection? You see, you see that in these two networks, you see they have two signal lines. For every port there are two signal lines. Okay, if this network, if any element is having only one signal line at the input and at the output, for example, let's take a resistor. Okay, if I draw a resistor like this resistor has only one signal, one end over here and other end, but here there are two terminals, right? There are two terminals over here. There is only one terminal at this end and another terminal at this end. So here in this case, these kind of elements, if they are connected in series, then that connection is also called as the cascade connection also, because in this case both series and cascade are the same. But when we talk about a two port network such as this, like this, and when you want to say series connection, the actual definition of series connection means, it does not mean that simply connecting them or joining them in a straight line. That's not the actual definition of series connection. Series connection actually means that if two elements are connected in series, when we say that when two elements are connected in series, it means that the current through those elements are the same. The current through the two element is equal. That is how, when you see if I say that when a resistor are connected in series, means one resistor will be like this, the other resistor will be like this, right? So now we say that two resistors are in series. So series means the current through those two elements are the same. The same current that flows through the first element is the same current that flows through the second element. Then only we say that the two elements are in series. That's not the only definition. Not only the current, what about the voltage? The voltage gets divided, or the voltage gets partitioned, or we say the voltage gets biased. That is what we say. That is, in series connection, the voltage, if two elements or if two networks are in series, it means that the current across the elements are the same, but the voltage across the two elements are different. Just like how you say for parallel connection. In parallel connection, the voltage across each element are equal, but the current across each element gets divided, right? Or the current gets divided and will be divided into for these two elements. In the same case, for series connection, it's the opposite. Series connection means the current through the elements will be the same, but the voltage across the two elements will be different or gets divided. So that is what the series connection is. So series connection means I want to join these two networks in such a way that the current should be same, but the voltage, the respective voltage must be different. So here we know that this is We know this is there's I1 and V1 and I2 V2 for both networks. So first let me join them. Okay, let me join them in series. So series means I will draw the first network like this, like so. Okay, I will draw the second network like this. Okay, and in order to show the partition of the voltages, I will draw like this. This is how we say that the two-port network are connected in series. This is N1 and this is N2. Okay, and see over here how the voltage is divided. You see, let V1 be the input voltage of the overall network. Let V2 be the output voltage of the overall network. Okay, let V1 dash, that is what is important, let V1 dash is the input voltage of N1, and let V1 double dash be the input voltage of network N2. In the same way, let V2 dash be the output voltage of network N1, and let V2 double dash be the output voltage of network N2. Okay, V2 dash is the output voltage of network N1 and V2 double dash is the output voltage of network N2. Okay, so you see the voltages are being divided. And what about the current? The current is the same. This is current I1. Okay, this is current I1. That is, I1 current is flowing in both the network, and also the output current for both the network is called as I2. Is called as I2. See, this is what we say when the network are in series. Series means the current through the networks or the current through the elements will be the same, but the voltage gets divided. In parallel connection, the voltage will be the same, but the current gets across the elements gets divided. So that's what this means. This is what we call as this. This is a difference between the series and cascade. Okay, so in series connection, we can say that the voltage are the ones that is being affected, right? How the voltages are being affected? That is, V1 is equal to V1 dash plus V1 double dash. Okay, that is, V1 dash is the input voltage of N1 of network N1, and V1 double dash is the input voltage of network N2, and V1 is the input voltage of the overall system. Okay, of the overall series connected networks. Okay, so the overall input voltage is equal to the sum of the individual input voltages. In the same way, V2, the output voltage of the overall network, is nothing but, or is equal to the output voltage of network N1 plus the output voltage of network N2. That is, V2 is equal to V2 dash plus V2 double dash. So from here we can see that for a series connection, it is the voltages that is being affected. So which means, now you ask yourself, which is the parameter that you are going to use in which only the voltages are being affected? That is nothing, only that the only parameter which does that is the Z parameters, right? Because according to Z parameters, for any network, when you say that for any network, we can say that V1 and V2, I'm going to write in matrix form, right? So V1, V2 is equal to Z11, Z12, Z21, Z22 into I1, I2. This is the matrix equation of the Z parameters, right? This is it. So what I'm going to do is that I'm going to express the Z parameter of this, I'm going to express the Z parameter of this, and then I'm going to add them to get this. So let's see what happens. So for network N1, right, for network N1, comma, here V1 dash and V2 dash, right, are the voltages. So V1 dash, V2 dash, okay, V1 dash and V2 dash. V1 dash is the input voltage of N1, V2 dash is the output voltage of N1, is equal to, and let it be Z11 dash, Z12 dash, Z21 dash, and Z22 dash. So Z11 dash, Z12 dash, Z21 dash, and Z22 dash. Okay, and the current are the same, I1, I2. This is the Z parameter of network N1. Now let's write the Z parameter of network N2. So for network N2, the input voltage is V1 double dash and the output voltage is V2 double dash. So therefore let Z11 double dash, Z12 double dash, Z21 double dash and Z22 double dash be the Z parameter of network N2, and the current is the same, I1 and I2. Okay, and we already know that the voltage, the overall voltage is being divided, right? This V1 is the overall voltage of the series connected network, input voltage of the overall series connected network, and V2 is the output voltage of the overall series connected network, right? So we know, so we can say that V1 V2, right? V1 V2 can be written as V1 dash plus V1 double dash, and V2 is equal to V2 dash plus V2 double dash, right? It's nothing. This is the matrix form of this equation. That's all. This is the matrix form of this equation. Okay. So here this can also be written as V1 V2 is equal to V1 dash V2 dash plus V1 double dash and V2 double dash, right? But we already have the equation for V1 dash and V2 dash matrix, right? What is the equation? It is Z11 dash, Z12 dash, Z21 dash, Z22 dash, I1 into I1, I2. See, this is the equation for V1 dash and V2 dash. And the equation for V1 double dash and V2 double dash is this equation, that is, this is nothing but Z11 double dash, Z12 double dash, Z21 double dash, Z22 double dash into I1, I2. So here, since the current are the same, I can take current common, right? I can take the current matrix common. So in that case, the equation now becomes like this, that is Z11 dash, Z12 dash, Z21 dash, Z22 dash plus Z11 double dash, Z12 double dash, Z21 double dash, Z22 double dash into I1, I2. See, that's all. Okay, now I can combine these two into a single matrix, and that is nothing but Z11 dash, this element will be added with this element, so it becomes Z11 dash plus Z11 double dash. The second element is Z12 dash plus Z12 double dash. The third element over here is Z21 dash plus Z21 double dash, and this is Z22 double Z22 dash plus Z22 double dash. Okay, into I1, I2. There. So what is V1 and V2? V1 and V2 is the input voltage and output voltage of the overall network. What is I1 and I2? I1 and I2 is the input current and the output current of the overall network, right? That is the same equation that I have written over here. That is V1 V2 is equal to Z11 Z12 Z21 Z22 matrix into I1 I2 matrix. See, so which means if I compare this equation with this equation, I can say that Z11 Z12 Z21 Z22 is equal to this, that is Z11 dash plus Z11 double dash, Z12 dash plus Z12 double dash, Z21 dash plus Z21 double dash, and Z22 dash plus Z22 double dash. Or in other words, Z11, Z12, Z21, Z22 is nothing but the sum of this Z matrix is the overall Z matrix of the series connected network, and that is nothing but the Z11 dash, Z12 dash, Z21 dash, Z22 dash plus Z11 double dash Z12 double dash, Z21 double dash, Z22 double dash. So what this means is that if two networks are connected in series, then the overall Z parameter of the network, is nothing but the sum of the individual Z parameters networks. Right? It is a sum of the individual Z parameter networks, which means that if you want to say, if two networks are connected in series and if you want to find its overall Z parameter, all you have to do is take the Z parameter of this and add it with the Z parameter of this. That's all. In that case, you will get the overall Z parameter. This is what will happen when the two networks are connected in series. Okay. Now next we have is the series parallel connection, right? So with this now you will be able to understand how to write the parameters of different connections, right? So here this is called as a series parallel connection. So what is the meaning of series parallel connection? This means that how we are going to connect these two networks is that at the input side these two networks are connected in series, and the output side these two networks are connected in parallel. That's what this means as series parallel connection, which it's a combination of both series and parallel. At the input side is series and at the output side it is parallel, right? So let's draw that circuit. It's a simple circuit. Same thing, just like how we have learned in the previous connection. We take network N1. Okay, I will just draw network N1 right this over here, and this is network N2 over here. Okay, and at the input side they are in series. All right, at the input side they are in series means it will be like this, right? This is how we say it. So in that case, if they are in series, then we know that the current will be the same. Okay, the current will be the same, but the voltage gets divided. So which means if this is the input voltage, this is nothing but B1 dash and this is B1 double dash. Okay, so this is what it means. The input side is in series. What about the output side? The output side is in parallel. So parallel means that also we have already learned, right? Parallel means this is parallel. That is, this term will be connected like this. This signal will be connected like this. Now these are in parallel. Okay, now this is called as parallel series. So in parallel connection means the voltage will be the same, right? So the output voltage will be the same, but what about the output current? That will be divided. The output current will be divided. This is I2, so therefore the output current over here gets divided into I2 dash and I2 double dash. This is how it is. This is how it looks. So in the input side, it is the input voltage that gets divided. At the output side, it is the output current that gets divided. Or in other words, the equation becomes, at the input side we have V1 is equal to V1 dash plus V1 double dash. At the output side we have I2 is equal to I2 dash plus I2 double dash, where V1 is the overall input voltage of the series parallel connected network, and I2 is the output current of the overall series parallel connected network. V1 dash is the input voltage of N1, V1 double dash is the input voltage of N2, I2 dash is the output current of N1, and I2 double dash is the output current of N2. And if you see this, so ask yourself now, which is the parameter that gets affected in such a way that the input side the voltage gets affected, and at the output side it is the current that gets affected. Which parameter do we use for that? By common sense, right? It's easy, right? It will be the hybrid parameter. Why? Because for any network, comma, the hybrid parameter equation is expressed as V1 I2 is equal to H11, H12, H21, H22 into I1, I2. See, this is how we write them. So now what you have to do is write the hybrid parameter of individual network and see for yourself what will happen. Okay. So for network N1, what is the hybrid equation, hybrid matrix equation for network N1? Here we see that the input voltage is V1 dash. Okay, let me write V1 dash, and the output current is I2 dash. So I will write I2 dash. Okay, is equal to H11 dash, H12 dash, H21 dash, and H22 dash. Okay, and this is nothing but I1 and I1, sorry, this is it's supposed to be I1 and V2. Okay, I made a mistake. It's supposed to be I1 and V2, right? That's the definition of hybrid equation, I1 and V2. Same way over here also, I1 and V2. Okay, yeah, I1 and V2. So this is for network N1. What about for network N2? For network N2, comma, we can say that what is the input voltage over here? V1 double dash, and the output current is I2 double dash. So V1 double dash, I2 double dash is equal to H11 double dash, H12 double dash, H21 double dash, H22 double dash into, and here the output, the input current is I1 as the same, and the right, because same current over here also, I1 is the same current over here, and over here the output voltage is V2. So here it is V2. This is how it looks, right? So now if we going to write the matrix equation of this expression, then it will become like this. That is, we know that V1 I2 is equal to V1 dash plus V1 double dash, and I2 is equal to I2 dash plus I2 double dash. Or we can also say that V1 I2 is equal to the matrix V1 dash I2 dash plus V1 double dash I2 double dash. Okay, and this is also, so we already have the equation for V1 dash and I2 dash, right? It is nothing but H11 dash, H12 dash, H21 dash, H22 dash into I1 V2, okay, plus this can be also be written as, this step can also be, this V1 double dash and I2 double dash can be written as H11 double dash, H12 double dash, H21 double dash, H22 double dash into I1 and V2. And here the matrix I1 V2 is the same, is common in both the terms, so you can take it outside. So therefore we get the overall equation as H11 dash plus H11 double dash, H12 dash plus H12 double dash, H21 dash plus H22 double dash, H21, so H21 double dash, and here H22 dash plus H22 double dash into I1 V2. This is how it looks like. Okay, here V1 and I2 is the input voltage and output current of the overall network, and I1 V2 is the input current and output voltage of the overall series parallel connected network, right? And if you look over, if you compare this equation with this equation, you can say that this matrix is equal to this matrix, or in other words, we can say that H11, H12, H21, H22 is equal to this matrix, that is H11 dash plus H11 double dash, H12 dash plus H12 double dash, H21 dash plus H22 double dash, H22 dash plus H22 double dash. Okay, oh, here is H21. I'm always making a mistake. This, or we can say that H11, H12, H21, H22 is equal to the sum of the individual matrix, that is H11 dash, H12 dash, H21 dash, H22 dash plus H11 double dash, H12 double dash, H21 double dash, H22 double dash. You see, So what does this means is that if two networks are connected in such a way that at the input side they are in series and at the output side they are in parallel. If two networks are connected like that, that is if two networks are connected in series parallel connection, as an input side is series and the output side is parallel, then they are hybrid parameters. The overall hybrid parameters is nothing but the sum of the individual networks' hybrid parameters. That's what it means. That is what you understand for a series parallel connection. Okay, that's what it means for a series parallel connection. Next we have is the parallel series connection. This connection I want you all to do by yourself. Okay, I have explained the remaining parameters. So the connection of the explanation of is exactly the same. So what is the meaning of parallel series connection? In parallel series connection means at the input side the networks are connected in parallel and at the output side the networks are connected in series. So which means that at the input side it is the current that gets divided and at the output side it is the voltage that gets divided. So hence we get I1 is equal to I1 dash plus I1 double dash and V2 is equal to V2 dash plus V2 double dash. So like I said before, ask yourself which parameter you are going to use in such a way that the input current gets affected and the output voltage gets affected. It's nothing but the inverse hybrid equation, because according to inverse hybrid we know that I1 V2 is equal to G11 G12 G21 G22 into V1 I2. That's how we call it as a hybrid equation. So in that case, deriving just like how we did in the previous connection, if you derive first you write the hybrid, the inverse hybrid of this equation of this network, and then you write the inverse hybrid parameter of this network, and then you know which one is divided, right? So you write the matrix equation for the overall network, and then finally you substitute the value of the values of the corresponding current parameter and the voltage parameter equation, and finally you will get this equation. That is, from here you can say that the overall inverse hybrid equation is nothing but the sum of the individual inverse hybrid parameter equations or matrix. Okay, so this is what we see for a parallel series connection. Alright, so as a summary, what have we learned so far? There are two things I want you to do. First thing is that I want you to prove this. Okay, and also I have not mentioned one more thing, that is, we have already learned for the cascade connection. Now, let me take that portion. Cascade, where is cascade? Yeah, for cascade connection I have already told you that we are using ABCD transmission parameter, right? So like that we have derived that for ABCD when the two networks are connected in cascade, the ABCD parameter of the overall network is nothing but the multiplication of the individual ABCD. Only the cascade connection has this property, no other property. Okay, multiplication. The rest of them are all addition, except the cascade. Here the transmission parameter is nothing but the multiplication of these two matrices. Okay, but now I want you also to prove the inverse transmission. The inverse transmission for the cascade connection, the inverse transmission parameter for the cascade connection is also exactly the same. Okay, I want you all to prove that. Okay, do that by yourself, then you will understand how it is being done. Okay, try to find the inverse transmission parameter of the overall network with respect to the inverse transmission parameter of the individual network. You will get exactly the same equation. Okay, inverse transmission of the cascade connected network, right? That is one thing I want you to do. And the second thing I want you to do is I want you all to derive this by yourself. That is, for a parallel series connected network, the overall inverse hybrid parameter is nothing but the sum of the individual inverse hybrid parameter networks. So here, only for cascade only the ABCD parameters and the inverse ABCD parameters are multiplied, or we find the multiplication of the individual matrices. For the remaining, that is for the Z, for the Y parameter, that is for parallel connection, for Z parameter, that is for the series connection, for series parallel connection, that is for hybrid, and for parallel series connection, that is for inverse hybrid. For all these connections, we simply add the matrix, we simply add the individual parameter matrix. Just need to add. Only for cascade only we multiply. For remaining parameters we correspondingly add its respective matrix. That's all. Okay, so this is what we learned. This is the only thing you need to understand for the interconnection of two-port networks. Okay.